Go.
Hi, my name is Ian Kerr, and for my molecule diary project, I chose the molecule dexamethasone, which actually has two molecular formulas, C22H29FO5 and NaN3. For today's purposes, we'll be focusing on the organic structure, the C22H29FO5. The reason I chose dexamethasone is because it's used in a treatment known as ionophoresis, which is a common treatment that is used at the physical therapy clinic I work at. So, when looking at the molecule, we see that there are a couple functional groups that can be identified. The first one, we'll start looking at the molecule and move from left to right, is right here. So we have a carbon double bonded to an oxygen with a carbon here and a carbon here. So this is a carbonyl with two carbons there, and that is known as a ketone. So we'll highlight that here. Down here. Moving forward, we also see that we have a carbon-to-carbon double bond here and a carbon-to-carbon double bond here. These are alkenes, so we'll circle those as well. The next functional group we see is up here. We have a carbon with a single bond to an OH. If we remember from our lesson 6 discussion, that is an alcohol. So we'll highlight that. Moving forward, we also see another carbon that has a single bond to an OH, so that's another alcohol. Then we have a carbon up here, also single bonded to an OH, so another alcohol up here. And finally, we see that we have a carbon with a double bond to an oxygen and a single bond to a carbon here and a carbon here. That's another ketone. So overall, we have 1, 2, 3 alcohols, 1, 2 alkenes, and 1, 2 ketones. So the second part of our video, we are going to focus on electron arrangement, molecular geometry, and hybridization. So I'm going to focus on this carbon right here. So we see that we have 1, 2, 3, 4 bonds with a double bond to the oxygen. So this carbon has its octet full, it's made its 4 bonds, it has no lone pairs, but since we have a double bond, it's not 4 electron groups, it's actually 3. So with 3 electron groups and no lone pairs, we have both the same electron arrangement and molecular geometry of trigonal planar. So we'll write that down here. Now, we also want to look at its hybridization. Since we have 3 electron groups, as mentioned before, we actually have sp3 hybridization. So we'll have sp2 hybridization. So we'll have 3 sp2 hybridized orbitals and 1 unhybridized p orbital. So the three sp2 hybridized orbitals will make a sigma bond here, here, and here. This unhybridized p orbital actually makes a pi bond from the C to O. So we'll write this here, sp2 hybridization. And for our non-central, or sorry, our non-carbon central atom, I'm going to focus on this oxygen up here. So this oxygen has a bond to carbon here and hydrogen here, and it also has two lone pairs to fulfill its octet. So we have four electron groups, so we would have a tetrahedral electron arrangement, but we have two lone pairs and two attached atoms. So that means we actually have a bent molecular structure, and since we have four electron groups, we actually have sp3 hybridization. So what this tells us is that this oxygen will have four sp3 hybridized orbitals, one that makes a sigma bond with carbon, one that makes a sigma bond with hydrogen, and one that houses each lone pair. So that is my molecular diary entry number 1 for dexamethasone. Thank you for watching and have a great day.